you will be required to approximate the binomial distribution with the normal distribution, and I'm going to show you why you do this. This is a graph for the binomial distribution where n is 10 and p is a half. You can see here that it looks quite blocky and there aren't many possible outcomes. It is symmetric around 5, but it's still very discrete. Now, what happens when we increase n to 100? You can see here that the bars are a lot more closer together and the overall shape starts to look a lot smoother. And now it's starting to resemble the familiar bell-shaped curve that you get with your normal distribution. Now, this is what the binomial distribution looks like when we increase n to 1,000 trials. The distribution is so smooth, it almost looks like the normal bell-shaped curve, and that's why we can approximate the binomial with a normal distribution when n is large. You can see how these discrete blocks sort of start to blend into a normal continuous curve. So as n grows, the binomial go from blocks to a bell-shaped curve, and that's why the normal approximation is used. The two conditions that allow you to approximate a binomial with a normal is when n is large and p is approximately 1/2. You need to know your parameters of how to estimate with the normal distribution, and luckily you don't actually need to memorize these because they are hidden in your formula booklets. So with Edexcel and AQA, you do get this table here. Your parameters for your approximation for your mean is n times p, and for your variance it's n times p times 1 minus p. This doesn't say normal approximation anywhere on here in the formula booklet. It's just something you can use in case you do forget. For OCR, this is also given to you, but it's just a lot more wordy here. That's there. Just don't forget, if you are approximating a discrete distribution with a continuous distribution, you do need to apply continuity corrections.